Good morning, students. Welcome to your chemistry class. Let us start with the discussion of the chapter Chemical Bonding and Molecular Structure. In our today's lecture, we are going to study hydrogen bonding, and in that we are going to cover its definition, conditions for its formation, types of hydrogen bonding, and consequences of hydrogen bonding. So, what is hydrogen bonding? Let us first understand with the help of an example. So, to understand hydrogen bonding, we should have a polar covalent bond. Now, how that will be formed? That will be between a highly electronegative atom and a less electronegative atom. And the requirement for hydrogen bonding will be, of course, hydrogen. So when a hydrogen is connected to an electronegative element, it will acquire a partial positive charge, and the electronegative element will be having a partial negative charge, because the electronegative element will be having a tendency to attract the shared pair of electron towards itself. Now, because of this partial positive and partial negative charges present, hydrogen of that molecule can be attracted to the electronegative element of the another molecule. Okay, and the bond that is formed in this case is known as a hydrogen bond. So what will be its definition? The electrostatic attraction between partially positively charged hydrogen atom bonded to the electronegative atom and another electronegative atom is referred to as hydrogen bond. So as we can see that there is a partially positive hydrogen atom connected to an electronegative atom and also connected to the electronegative atom of the another molecule. Now, what are the conditions for its formation? The first condition is that the molecule must have a highly electronegative atom linked to hydrogen atom. So, there should be a hydrogen atom linked to an electronegative atom. The second condition is that the electronegative atom should have small size. So that means only fluorine, oxygen and nitrogen atoms fulfill the above two conditions and can form hydrogen bonds because they are small in size as well. The size of chlorine atom is large, so it does not form a hydrogen bond. Similarly, sulfur is also a large atom, so it will also not form a hydrogen bond. Now let's study types of hydrogen bonding. The first one is intermolecular hydrogen bonding and the second one is intramolecular hydrogen bonding. So let's study them one by one. Intermolecular hydrogen bonding, let us first take two examples. Now in this we can find that there is hydrogen bonding taking place, but in one case the molecule are same and in the one case molecule is different. Here we have taken an example of methanol dissolved in water. So when we talk about intermolecular hydrogen bonding, we should know that the hydrogen bond formed between two different molecules. So in this case, the hydrogen bond is formed between two different molecules. Means here that one F is not connected to the same hydrogen of the same molecule. Okay, so the hydrogen bond formed between two different molecules. Now that molecules can be same molecules or they can be different molecules, and such type of bonding is referred to as intermolecular hydrogen bonding. So in this case we can find that the hydrogen of one molecule makes hydrogen bond with electronegative atom of another molecule. Now in this case some other examples that we can consider is water. Now we know that oxygen is highly electronegative and hydrogen is electropositive in nature, and due to this they will be getting a partial positive and partial negative character. So the hydrogen which is connected to the electronegative element will also be forming a bond with the electronegative element of the another water molecule because of the electronegativity difference, and this will give rise to hydrogen bonding. The same is the case with formic acid molecule. One formic acid molecules connect with the another with the help of a hydrogen bonding. The second one is intramolecular hydrogen bonding, and in this case we can see that the hydrogen bond is formed between the same molecule. So the hydrogen bond formed between the same molecule is referred to as intramolecular hydrogen bonding. So we have taken example here of orthochlorophenol, orthonitrophenol, orthohydroxybenzoic acid. Now, what are the consequences of hydrogen bonding? The first one is dissociation. Now, when we see the dissociation of hydrofluoric acid, and in that case, when hydrofluoric acid is dissolved in water, it dissociates to give difluoride ion, that is HF-2 instead of F- ion, that is fluoride ion. So what is the expected one? That whenever HF will dissociate, it will form H positive and F negative. But what we find here is HF2 negative because of hydrogen bonding. The another one is association. Now when we talk about association, that means two molecules coming together, associating themselves, and this may give rise to an abnormal molecular mass. So some molecules exist as dimers or trimers or polymers in non-aqueous medium or in vapor state due to strong intermolecular hydrogen bonding, and such example is of acetic acid exists as dimer in benzene. The molecular mass of acetic acid is 60, but when it is dissolved in benzene, it forms a dimer, and the molecular mass that we observe in this case comes out to be 120 grams. So this is because of hydrogen bonding. The third one is high melting and boiling points. So when we take an example of water and H2S, we find that the boiling point of water is quite high as compared to hydrogen sulfide. Also, we know that hydrogen sulfide is a gas while water is a liquid. So why this happens? This is all because of hydrogen bonding. So the boiling point of water is high, that is 373 Kelvin, and it's due to intermolecular hydrogen bonding, and hence it exists as liquid at room temperature. Hydrogen bonds are absent in the case of H2S, and hence it has a low boiling point and it exists as a gas at room temperature. Now let's study about the solubility in the case of hydrogen bonding. The solubility of compounds showing intermolecular hydrogen bonding in water increases due to formation of intermolecular hydrogen bonds with water. We know that there is electronegativity difference between the water atom also. So if we talk about ammonia is also having electronegativity difference between nitrogen and hydrogen. Due to this, there is a hydrogen bonding formed between ammonia and water. This will increase its boiling point. So other examples are of ethyl alcohol, methyl alcohol, ammonia, hydrofluoric acid, acetic acid, etc. They all are fairly soluble in water, and this is because of the ability to form intermolecular hydrogen bonds with water. The next one is the unique properties of ice. Now we know that each water molecule can form 4 hydrogen bonds in tetrahedral geometry. This we already know due to presence of 2 lone pairs on oxygen atom. Now why density of ice is less than water? We know that ice has less density than water due to stable hydrogen bonding present in ice. At a low temperature, these hydrogen bonds which are present in ice will get freezed up, and therefore this will create more stability in it, and there will be vacant spaces in the ice which will help its density to decrease. But in the case of water, these hydrogen bonds are not stable. They constantly break up and reform. But in ice, they are stable and cannot be shaken out of position due to insufficient thermal energy available at low temperatures. So therefore, ice floats on water, but water has more density as compared to ice. Now, why some substances show high viscosity, low volatility, high heat of vaporization? This is all because of hydrogen bonding. Now, let us take example of glycerol. Glycerol is more viscous. We know that due to presence of 3 hydroxy groups, because more the hydroxy groups, more will be the hydrogen bonding in them. So, per molecule of glycerol can make more hydrogen bonds. So, this will increase its viscosity. The last one is the strength of certain acids and bases. Here we take an example of salicylic acid. Now, strength of certain acids and bases can be explained on the basis of hydrogen bonding. For example, let us take salicylic acid. It is a stronger acid than its meta and para isomer. So, if we consider orthosalicylic acid, it is more stronger as compared to its meta and para isomer. Why this is so? This is all because of hydrogen bonding, because the fact is that the salicylic acid easily furnishes H positive ion. Because why does it furnishes H positive ion and form a salicylate ion is, as soon as it will release its H positive, it can form hydrogen bonding with the adjacent hydroxy group which is present, and this will give rise to intramolecular hydrogen bonding in salicylic acid, which is an ortho isomer. So in our today's class, students, we have studied what is hydrogen bonding and what are the different consequences of hydrogen bonding. Thank you so much.